In this short tutorial, I'm going to teach you how to do trihybrid crosses using Punnett squares, and this is actually much easier than you would think when it's explained clearly. So let's do it with a worked example, because I think a worked example is the best way to teach this. So we're going to look at a trihybrid cross where the organism is heterozygous for all of the traits. So we've got the cross as shown below. And so the first step in putting together a Punnett square is to determine all of the possible combinations when we come to form the gametes. So we've got the genotype there with the three different traits. And so let's imagine that we picked the first capital A. So we're looking at just that one dominant allele, and we look at all the possible combinations. So you're just taking the first letter A and then doing all of the combinations of the dominant and the recessive for trait B and trait D, and that gives you that list. Then we say, what if you were to pick the recessive form of A? And then you do that and you work out all of the possible combinations. And actually, and very conveniently, this covers all of the possible arrangements. And if you wanted, you could prove that there is 8 with factorials, but we're not going to go into that because there's only 3, so you can just work out all the possibilities quite easily. And you can see that if you tried anything else, it's not going to work. So we've now got all of the possible arrangements of this, so we can set up our Punnett square by simply copying those over, and that will be our row headings and column headings. So we're going to get the Punnett square set up as so. So this is just like a normal Punnett square, and we just start working through all of the possibilities by combining them. So for example, we're going to have the first column is going to come like this. So we're going to be dominant for all of the characteristics. We're then going to move on and do the next one. And obviously it's pretty much the same thing, except you're getting the recessive D from the column. And then we just keep going with this pattern, and we could fill it all in. To make life easier, there are some patterns so you can do it a bit quicker. So you'll notice that certain quadrants match up. So the first quadrant in the top corner, it's dominant for A, and then you get repeating patterns in each of the quadrants, and then you can fill it in by rows and fill it in by columns, and that tends to be the fastest way to do it. So if you were to fill it in, you get this, and it's pretty unwieldy. It's very difficult to look at that and draw any conclusions. It just doesn't make very much sense. If you wanted to look at one individual square, you can tell what the phenotype would be, but it's not particularly helpful in this form. So what we can do is we can actually color code it. And when it's color coded, it's much clearer, or you can put some sort of drawing on it or otherwise identify each of the phenotypes so you can analyze it. And so the way that I do that is I start by looking at those that are dominant in all. So for trait A, trait B, and trait D, they're all got dominant. So you've got one dominant allele, and therefore that's going to have that phenotype. And so I've shaded all of those in. And then you just have to work systematically and identify each phenotype individually. So I say dominant in all except recessive in A. So you're looking at those that have a recessive trait A, but I've got dominant for all of the others, and I highlight those in a different color. Then you could perhaps go on and do something else. So dominant in all except recessive in trait B, and that fills in a little bit more. And then you're going to look at dominant in 1, recessive in 2, and then just keep going until you've covered every possible one. So you have colored in the entire Punnett square. And once you've done that, you'll start to see things come out. So I've done this. I've just put a different color for every different combination. And when you look at all of the phenotypes, you get the phenotype ratio, which is 27 to 9 to 9 to 9 to 3 to 3 to 3 to 1. And that is the genetic cross complete. So hopefully this video has been very helpful to you, and you can now do trihybrid crosses. Thank you very much for watching.